Hi everyone, I'm Susanna, and today I'm going to be demonstrating the design that you've been working on the lab, actually running on the board. Okay. The board we're working with is the Stratix 10 SoC Dev Kit that comes from Intel. It is a very large board, so don't be surprised when you take it out of the box if it's very large. Actually, the box is very large, so you probably will not be surprised. When you take it out, you will need to connect some daughter cards. Some things that are already on there, though, is you'll see the fans. They come connected just out of the box. It's water cooled, so you'll see these tubes running from over here to the heatsink, and that's why, because it is providing liquid cooling. And then, like I said, you'll need some daughter cards. The daughter cards are in the box. They're just not connected up to the main board yet. So the ones that you'll need to connect, let me go ahead and show you those to run the GSRD, which is mostly what we'll be working with today. It's just a slightly modified version of the GSRD. Okay, so first you'll need this QSPI card right here. And that is what we'll be writing. What we've been talking about goes into the QSPI image, so that will go into the QSPI right here. Okay, so connect that one up. You will need some memory. This is the memory that the HPS talks to. So this will come in a little daughter card that looks like this. There's actually some of that card is underneath this mechanism that keeps pressure on it so that it will stay connected. So this is just a little piece that's connected to these connectors, and this just presses down on it so that it stays. So there'll be four, when you're looking for the card in the box, there will be four components on it. One is just under here so you can't see it. So put that on the board, put this on top of it, and then put these pins into it to keep it pressed down. Then the other thing that you'll need is this daughter card up here. This provides some of the I/O connectivity and data connectivity that we need to make the HPS work. So this board is, the outline is here. Okay, so it has the SD card socket on there, or the connector, and then it also has an Ethernet connector. I don't have a cable hooked up to that, so we won't be doing anything with Ethernet today, but the standard GSRD does do some neat things with Ethernet if you do want to connect it up and play around with it. And then also the connection to the UART is here. So this there's a chip on here that interprets UART protocol encapsulated into USB, and that's an FTDI chip, and that's what we're actually speaking to the UART through the computer with. Okay, this is a pretty standard way to do UART communication nowadays. Okay. And I'll talk about the cables in just one second. Okay. The memory card that you see here, this is not necessary. This is just something that I had on my board that I couldn't get out once I put this card on, so it's just been a permanent fixture. It's for other memory memory controllers within the FPGA to talk to if you wanted to, but you don't. It's not required to run the GSRD. The cables that you need to set up, so this one here is going to provide the UART communication. It is connected to my laptop on this side that's not shown, which is standard USB, and then the side of it is mini USB. Okay, so pretty standard cable. That also comes in the box. All of the stuff that I'm talking about comes in the box. You don't need to go buy anything extra. And then this cable here, that is actually connecting to a chip right here that is an onboard USB blaster. So that means that it can program the FPGA. So we don't need those large programming cables that you might be used to. Today we just usually build it onto the board to interpret the protocol, and we just talk USB to it. So this cable that's connecting to do this is just a standard USB on one side and a micro USB on the other, which is a very standard cable these days. A lot of phones use it to charge. Okay. And then down here is the power cable. This is a very bulky power adapter and cable. You will notice that when you take it out of the box, but this is where you connect it up. Okay. And then here is a switch. The FPGA will not be powered until you flip the switch on. If it's off, then that will gate the power to going to the FPGA. Interestingly, though, the UART will be powered just as soon as you connect this up. So that means that you can start up PETI before you actually boot the FPGA, which is good because then we can see the whole boot sequence as we go through it. Okay. Okay, so there's a couple of steps that I did before what I'm going to actually demonstrate today, and that's because they take a while, and it would make the demo too long if I did it while you're sitting here. So the first thing is that I wrote the SD card image, the same one that you have been working on in the lab to build up, onto the SD card. So in order to do this, I put the SD card into my laptop. Some laptops have slots. Sometimes you need a little, USB dongle that interprets USB to SD card, but somehow get that connected up to a computer so that you can write to it. I'm running Windows, so I used Win32 Disk Imager. If you're running Linux, then the normal way would be to use the command DD. Okay, so Win32 Disk Imager, you just point it to the image, tell it which device letter that your SD card has been mapped to by Windows, and then you would hit write, and it would take a while. It took me about 32 minutes. I think this is slower than if I had not been using an Intel laptop, but it would just do expect to sit there for a while it writes. Okay. Later on, if you need to change the files on that SD card, it's a lot easier the second time. You don't need to go back to doing the complete image. You can just put that SD card into your laptop, and the FAT partition, you'll see all the files if it's a Windows laptop, and you'll be able to change them. If you put it in a Linux system, you'll also be able to see the ext3 partition. Many times, the people for the ext3 partition, you could just actually communicate when that SD card is popped into the board itself. The Linux that you're running would be able to write to it. So these are the files in the FAT partition are usually the ones that you'd want to go back to your laptop and write them. Okay, and after you have written your SD card, so the step that we talked about here, then place it here. So don't place it there till you've already written to it, the initial image to it. Okay, then the next step, we need the board to have a QSPI image sitting there so that the FPGA can turn on and then read a valid image and start running that. So the command that we'll use to do that is Quartus PGM. This will also take a while. It takes about 5 minutes. And before you run this, make sure that switch 2 is set to on. Sometimes the QSPI is set to talk to the SDM, and sometimes it's set to talk to others. So this is just enabling that the proper connectivity to actually be able to write to it. Okay. Then the command you'll use is Quartus PGM. This is the standard setup and naming and such that we use with the GSRD. Your name might change slightly if you have not followed the exact tutorial, or if you have a different board, because some of this naming corresponds to which QSPI part you're using and what FPGA that you're using. Okay, so after you run that, you wait for a while. You'll see a lot of output to the screen, and then after about 5 minutes, the QSPI will be written. All of this is documented at Rocket Board, so they feel like you have to memorize it right now. Okay, and before you get ready to actually use the board, you need to set that software, sorry, I keep saying software, you need to set switch 2 to on, off, to have the designs actually run properly. Okay, so now I'm going to go ahead and start the actual demo part of this. The first thing that you will need to do, I already know my COM port, but I'll show you all how to get this. The COM port that the cable that is running the UART connectivity to is mapped over USB. So we need to see what that COM port is actually called, so we can tell PETI that. Okay, so to do that, you go to ports, COM, and LPT if you're running Windows, and you will see something that says USB serial port, and you want to take note of what this is. So for me, it's COM4. Okay, so now I'll run PETI. And you don't have to run PETI as your TTY program. You can run any TTY that you like best. A lot of people do like PETI, so this is pretty standard. Okay, so I'm going to write this in like I didn't have it saved away, and then I'll use my saved one just in case I made a mistake. So here I'm putting my, well, actually, let me do this first. So first you want to switch it to serial. Then you want to put where that serial line is. So what is the name of it that we looked up before, so COM4. And then the speed, and this is pretty standard nowadays, is 115/200. This actually is configured in U-boot and Linux. So there is, you know, if your software person was very creative, they might have changed this, but this is pretty standard and there's not a big reason to change it. So almost always, you know, this is 115/200, just like the GSRD would have. Okay. Okay, so that's, I think I got it right. If you want to save it away for later, so this is, I have my settings saved, you can say save and it will save those, this session setup. I have mine saved away here, but I'm pretty confident this is correct. So we'll go ahead and say open. Okay. And since I have not switched the board on yet, we're just seeing nothing yet, nothing right now. When I switch it on, then I'm going to do that right now, you'll start seeing output to the screen, which is our booting happening. So first we'll see U-boot, and then I'll stop it, we'll do some things, and then we'll see it boot to Linux after that. Okay. Okay, I just flipped it on, so we're starting to see messages to the screen for booting. I'm going to stop it by pressing a key. Okay, and I'm now in a U-boot prompt. Okay, so we're going to do a few things here before we move on to Linux. Okay, so there's actually quite a few things you can do at the U-boot prompt. So if I type help, I can see that there's quite a few commands that I can do right here. So even things like unzip, if a memory region was zipped, I could do it, you know, within here. I can run things, load things, see files, write into files if I wanted to. So, you know, quite a few debug capabilities that I can do just within U-boot. If I was, you know, for example, having trouble booting to Linux, there might be something I could do within U-boot itself. Okay. Another thing that you might want to know that you can do, if I type print env, then I see all of the env setup that has been done. So these are all of the, a lot of these are commands or locations of files or names of files that I need U-boot to know about because it needs to find them during the boot. Okay. So one of the important things that's set up in that environment is the boot command, and this is what U-boot runs as a standard boot. So I see here the boot command was set to run the FAT script, and that is that uboot.scr that has been talked about in class. Then run mmc load, so that runs the grabbing the file, the Linux image from the MMC, and then it runs the QSpy enable, and then some RSU functionality, and then it runs the MMC boot. So these are just standard boot commands, but if you want to dive into what is actually happening, that is the command you will look at. That's all actually all the chain of commands that make up the boot from U-boot's perspective. Okay. Okay, so if you happen to stop it during U-boot like I just did, and then you need it to go ahead and keep on going and boot Linux, then what you do is say run boot command. If you didn't stop it, it would just go ahead and naturally run the boot command. So I'm just telling it to go on like it normally would. Okay, and what I see here now is Linux booting up. So all of these are messages that are coming from the Linux boot. And we are going to see a few things. Yeah, so we see a lot of OKs happening here. I am going to see some things that failed. That's all the Ethernet stuff because I don't have the Ethernet cable connected. So some of those things it's not able to start, which is, you know, expected. Okay, so then I get a logon prompt. This is my Linux logon prompt. Yeah, and there's always this very last message that comes up after you think it's all done, that it finally times out and disables. I think it's the Ethernet port, so that's also expected if you don't have an Ethernet cable connected. Okay, so the login is root. I typed that here before that very last message kind of interrupted me. So once you click that, I'm now at a Linux prompt. Okay. Okay, so let me see if I can Yeah, I should have made this bigger beforehand, but there we go. It's a little bit bigger now. Oh, now it's a lot bigger. Okay. So now let's run some things from Linux. So y'all have been working on modifying the design. So let's see some of that, how some of that showed up. Okay. So let me clear my screen first. Okay. And now we talked, or Jossie talked with you about how there's some special directories within Linux that correspond to some of the devices. So what I'm going to show you is some of the /sys directory, which is one of those special directories where some of our peripherals are showing up. Okay, so here I'm going to show you, and there's tab complete if you wanted. I'm pressing tab to complete some of the stuff. So here I'm showing you that we added a new GPIO. So that's the GPIO that was added in the lab. Then we're going to go ahead and CD into the devices because we mapped it as a GPIO, and then we said the type, then we mapped that GPIO as an LED. So what we really want to see is that LED that's been mapped. So it's mapped, the things that were added were mapped both as GPIOs and like a special type of GPIO that was LEDs. Okay. Okay, so now we're in the /sys/devices. We'll be able to see those LEDs that we added. Usually you don't know exactly where they show up, so I'm showing you what I would do if I didn't have a cheat sheet. So I would do a find .-name and then give it part of the name that I gave those new LEDs in the device tree. Okay, so I see them here. That's what I named them in the device tree. And so now I know how to get to them. Okay, so we'll go ahead and push down even further. Okay, and here's all of those LEDs. Okay, we'll go ahead and go down one more directory so we can actually interact with this LED. These LEDs too are, they're not mapped to pins. The board unfortunately has very few actual blinky lights that I can use without connecting up yet another daughter card. But if you wanted to connect it up and signal tap to see those things wiggling, you could, and they are wiggling internally in the FPGA. There's just not connected to a pin. Okay. Okay, so there's some things that you can do with LEDs that are just defined by how it gets mapped, and these are documented along with the driver documentation. So here, or you could just look online. LEDs are, you know, pretty old technology, so all of the driver and how it's mapped to Linux has been documented. So here, within where it's mapped in the root file system, I can do triggers and brightness. The brightness is like a pulse modulated brightness. So first I'm going to turn off the trigger. Oh, first, actually, let me show you. So there's, all of these are characteristics that I can change just by writing into, you know, basically the file system. So this, I write into it like it's a file, but it's actually a property of that LED. Okay, so one of the things I can do is turn off the trigger. Okay, let me Control-C out of that. Okay, let me... Okay, trigger. I don't know why this is doing that. Okay, let me clear the screen. Hopefully that helps. Okay. Okay, so I just turned off the trigger. Now let me, oh, I think my shift key on my laptop is messing up. Okay, y'all forgive me for any input weirdness. It's actually my keyboard acting odd. And then I'm going to echo a brightness into that LED, and that will change how bright the LED is. And once again, I don't know why. Okay, let me try that one more time. Don't know why my keyboard is having such issues. Okay, well, I can't get it to behave, but let me show you what I just typed. Okay, so this is the history of all the commands I ran just now. So you see the echo into the brightness, and the echo here, that into the trigger. That was kind of messing up at the prompt, but it did get, you know, executed. And so if you had that mapped to an LED, you would see it get brighter, and you could, you know, tune it to whatever brightness you'd like to see. Okay. And that's what you added in the lab. So that wasn't there before you did your job or did your work in your lab. So that's it for the demo. I'm going to go ahead and end the recording now. And I hope y'all had a good class.